So if I may ask the next speaker, who's also a remote speaker, and that's Yousef Makdisi, also from Brookhaven. Yousef.
I should point out that it was Anatoly Zelinsky who was supposed to give this talk, in particular because Anatoly actually worked heavily with Willy and in developing this jet target, the analysis. But Anatoly is actually in Moscow now. He's been there for the last 2 months, and his connections are not very good. So he referred to me again to do this presentation. For that purpose, I specifically used his SPIN 2018 presentation, which is extremely detailed, not for this conference, at least the symposium. And the other credit is for Poblagiuev, Andre, who has done the phenomenal jet data analysis, which you will see in this presentation. And of course, the credit goes again to the spin physics group, the Rick polarimeter group, actually at the physics department, who, as Thomas described, are heavily involved in the analysis and running the analysis of the Rick polarimeters, the p carbon polarimeters. It's not allowing me to, I'm having difficulty pressing the, here we go. I think Thomas already mentioned the polarimeters in RIC. Actually, in addition to the 2 in RIC, there is 1 in the AGS and 1 in the LINAC to make sure that we are able to deal with polarization properly everywhere. The preamble here is to show you what, how this developed actually. Initially, as a RIC spin group, actually, we thought, we considered polarized jet target for RIC with the idea that the analyzing power is about 5% or so, 4 to 5%. But then we looked at inclusive pion production, which has a very large analyzing power. But the issue was, can we do the same with carbon targets? We ran an AGS experiment, and we found that the polarization or the asymmetries coming from carbon targets is the same as hydrogen targets, which we want to use for RIC, and this was our plan. So I went in 1998 to Praha to make the presentation about the RIC polarimeters from this pion production project. At the intervention there, at the recess, Willy comes to me and he said, you know, this idea is not a good one. Let's think about a polarized jet target. And he offered actually something called Pintex. I think it's from IUCF, if I'm not mistaken. At the same time, a bit later, collaborators from INFN were planning to do similar things with the PP to PP experiment at RIC. But unfortunately, a bit later, they did not provide support. So Thomas Roser contacted Willy again, and we had a meeting in June of that year at BNL to provide the basis for the conceptual design, and this started. We had a DOE review within a couple of years. We suggested $1.5 million budget. They agreed, and we started the process. The jet target was finished and installed in 2004. The data were taken with blue beam only at that time as a test. And then in 2005, we started taking data with both the blue and the yellow RIC beams. Actually, it's interesting. I was only a project manager actually in there, and DOE was skeptical that we would be able to do to the budget. And so I was getting phone calls once a month to describe to them where we are and what we're doing. And we'd actually managed to do the whole job with $10,000 remaining from that budget. Surprising. Now, this is the H-jet polarimeter, and it was commissioned, as I said, 2004. It was designed to measure the absolute beam polarization for basically at any energy in proton beams in RIC. For the experiments, the plan was to have delta P over P of the order of 5%, which we achieved in 2006, actually. The atomic hydrogen polarization of the jet was roughly 96%. And this was because we had the magnet was 1.2 kilogauss. We could have gone up by a couple of percentage points, but we didn't want the magnet to be too strong to bend the scattered targets, actually the scattered protons, very low energy scattered protons from the silicon detectors. The intensity was 12.6 times 10 to the 16. The density 1.2 times 10 to the 12. And the polarization was flipped using the strong and weak field resonances every 10 minutes. And basically you see the picture for the recoil targets. Actually, these were silicon detectors about a little over a meter away from the collision point. This is the picture of Anatoly and Willy at it. And Anatoly says that the conventional technique of pressure measurements in the compression tube was used, and Willy used his Swiss watches for the measurement of the timing. So it goes. And this below that, it shows the analyzing power, the predicted analyzing power of PP elastic scattering. The vacuum system was actually unique in this. The system was basically built with the same systems effectively all the way through from the top to bottom. And each chamber had two pumps in them, actually, except for the first one, the dissociator. And that was really a simple system, actually, overall. It was these oil-free pumps of 1,000 liters per second. It was a pretty good system, which really lasted. And I should say it's been running from 2004. I think we replaced one pump since then, surprisingly. Here's the optimization studies that Tom Wise, Willy, and Koster did for the magnets, where the RF cavities, and the rest of the system, the Bright-Rabi polarimeter, actually. I'm not sure personally why this was unique. Actually, distinct feature was the 65 centimeter gap between the two magnet groups, actually. But it looks like things work out exceedingly well. This is the analysis, again, by Tom Wise et al. To show what the beam intensity profile would look like. And the right plot is what we measured, actually. Pretty good in terms of what was expected. Very nicely done. And this is the plot showing all these targets. And actually, you'll see where Tom Wise calculations were actually at 9 times 10 to the 16. And the H-jet target was close to 12.5 times 10 to the 16. Tom Wise should complain, but he should be happy that it was so much higher, actually, in that regard. It was very, the maximum ever done. The transporting of the jet target was done. Of course, we did it actually more than once, going in and out in the first few years, actually. And the right picture shows the jet target, in fact, installed in RIC. I should say the jet target did not really impact the RIC beam vacuum system dramatically. It was, within a factor of 10 or so on either 1 meters or so around the beam pipe. We even installed emittance measurements actually by luminescence monitors on the HJet perimeter, and it shows you here a picture of what the two beams look like. Actually, the two beams were running concurrently, and they were separated vertically, and with the jet measuring in both the blue and yellow at the same time. We did an upgrade actually a bit later around in 2015 by basically having new silicon strips having run for about 10 years, new detectors. We added additional detectors to increase the range actually, and we were in a very good position we actually increased the amount of data taken in a film actually by almost a factor of 2. The data acquisition was upgraded as well with new WFDs from the JLab collaborations. Here's a result in 2017. In a typical 8-hour store, the polarization was measured as 56 ±2% statistically and 0.3% systematically. Now this systematics 0.3% actually was the real work of Andrei Poblaguev, who did amazing analysis, in particular about the molecular hydrogen, which he was able to evaluate running with both with RF transitions being turned off, as well as the background coming from the molecular hydrogen diffusing from the chambers above and below the transition point, the collision point. This is the details is in the PSTP 2017 actually, quite a good analysis. Now, having done such a good analysis, actually, Andrei went a bit further. He did, once you do the beam polarization, he's able to use both the beam polarization and the jet target polarization to measure both the analyzing power A sub n at 100 GeV and 255 GeV, which you see the data here. And then he did the A and N measurements as well at 100 and 550 GeV. 250 GeV. Doing this, having done this actually with such good precision, he was able to basically measure the real and imaginary of R5 and R2 to enable a separation between the Pomeron and Runge contributions to elastic scattering. This is already has been published in PhysRev Letters 2 years ago. Now, as you all know, RIC is a heavy ion program actually. So in the last few years, we were heavy ions running in RIC, and we decided, this is actually the credit to Anatoly Zelinsky, decided to run the jet at the same time, and Andrei Poblaguev analyzes the data. And here is the analyzing power actually of PP, in both the blue and the yellow ring, and then P aluminum and P gold. It's amazing actually, these data. And this is only at 100 GeV. We have additional data because RIC has run in the last few years actually with much lower energies as well. And we have the data which is yet to be analyzed. On the right-hand side is a P carbon analyzing power. And this was done actually using the beam polarization and then using the P carbon polarimeters to do the analyzing power of P carbon elastic scattering. It's interesting actually, the P carbon and the P aluminum look very similar in some ways. Now the T range in the P carbon goes further out than we can do with a jet target. But it's interesting to show you what the physics can be done here. Now, this indeed, actually, the HJet has become an absolute high precision polarimeter, high event rate, good analyzing power and a wide energy range, Non-destructive, we really don't have an impact on the beam. No scattering for the recalled protons. It's all windowless, point-like target, clean elastic scattering, event identification, straightforward calibration with the Bright-Rabi polarimeter, which is on the bottom side of the jet. And the false asymmetries actually has been done using the beam and the target. And as I showed you earlier, the typical result for the 8 hours, again, 2% statistics and basically hardly anything in the systematics. This is really great. So the question is there life beyond RIC? Of course, the AIC polarized proton polarimetry, the jet may be used, but the data acquisition system has to really deal with a different bunch spacing in RIC, actually. This has to have been redone. And of course, there's a plan for polarized helium-3, as Thomas Roser mentioned. And so just recently, in Spin 2021, there's an article that says, can the AIC helium-3 beam polarization be precisely measured with the H-jet? This is by a group from Brookhaven with Nigel Pottimer as a theorist in this game. So it looks like things are really going quite well, and maybe there is room for this jet again to continue. By the way, in the next few years, with the new S-Phoenix experiment being put together right now, there will be a polarized proton running actually for 1 year for S-Phoenix as well, where the jet will be used. That's about it. Thank you. I should say, I hope that Tom will answer some of the questions, if any, about the jet internally, the jet details itself.
Thank you very much, Yousef, for a fantastic talk. And I'm sure there are questions. Tom Weiss has a question.
I can't hear him at all.
Hi, Yousef.
Hi.
So actually, this is not a question, it's a comment about the contribution of Wujing Meng on the magnetic calculations. And that was just over the top. It was weeks and weeks and weeks and weeks of calculations that he did. And that's basically why we have such an incredibly high atomic beam polarization, because of his calculations.
Tom, you're absolutely right. Actually, Wujing has done a wonderful job in that regard, in a way. And he continues to, well, he just retired actually, but he continued to do similar calculations for other systems as well. But for the jet, he really did a good job on that, indeed.
Thank you, Tom. Other questions? Okay, if not, we can just start early. First of all, let's thank Yousef profusely